I'll tell y'all a story about 6th period when I'm not recording. All right. So here's our, this is going to 154. And here are our properties of ellipse. So here's nice pretty pictures. We're going to label some other ones. But you have this center point. Okay, there's a whole lot of stuff going on here. We'll label some other stuff here. But we have a center. You have 2 vertices, not just one. And then you have something called a covert. You have 2 co-vertices as well. Okay, so vertex and a co-vertex. And you're either going to have a horizontal or a vertical orientation, right? Then you have the line segments that connect the vertices, and the co-vertices are your axes. So you have a major axis and a minor axis, which should totally make sense, right? The longer one is the major axis. When you look at these 2 equations, the x, they're both squared. X minus, because it's very similar to a circle when you look at it, and to a circle in the equation, but it's different. Because if I didn't have the denominator here, and I had this, then this would be a circle that was centered at HK with the radius of 1, right? Or if the radius was 20 or whatever, I could divide both sides by 20 and end up with a 1 over here, but then these 2 numbers in the denominator would both be the same. Does that make sense to you? Then it would still be a circle. We wouldn't really work it that way, but we could write it in that form. But here these 2 are different. And what decides which way it's oriented is which one has the bigger number underneath it. It's not that A always goes with X and B always goes with Y. It doesn't work that way. A is always the bigger number. So one thing I want you to write right here is that A is greater than B, which is greater than 0. Because if they were 0, then it would be undefined, and that wouldn't work out for you at all. You agree with that? Okay. And then if I want to find the length of C, so we've got these lengths that are important to us. So when you took your string and you pulled it tight, right? If I was right here by the center, this distance between the center point and B, which is on the minor axis, this length right here is B. The length from the center to the vertex along the major axis is A. Okay, so that's where these A and B are coming from right here. This length is A, this length is B. And so since A is always the bigger number, it always goes with the major axis, and that's what's going to turn your ellipse. The distance the focus is from the center point, that is your C length, and you get it this way, which looks very much like what? Pythagorean theorem. But is it? No, it's not. So you got to make sure you know, remember that it's different. We're not doing Pythagorean theorem there. It is C squared is A squared minus B squared. It's going to be really hard to subtract those backwards if you understand what they are, because A is always bigger than B, right? And you're not going to end up with a negative number. Okay, we okay with all that? So we're going to label some stuff on these middle pictures before we fill in the little charts here. So here's just 2 of the same pictures again. And this here is that since it has a horizontal orientation, this is a vertex, this is a vertex. These 2, what are these 2 called? Co-vertex, so we'll put CV for co-vertex. This is the center point, but I'm not going to put a C there because I don't want you to get it confused with the other C. One's capital, one's lowercase, but with the letter C, it's hard to tell, right? This is my major axis. The foci is plural for focus, by the way. The foci are always on the major axis, always, which is always the longer one. And so the distance from the center to the vertex along the major axis is A, because A is always bigger than B. And then the distance from the center to the co-vertex is B. And I know that's labeled up there, but I want you to have it labeled again that we're actually writing it in. Then these 2 points here, this is a focus. This is like focus 1, and this would be like focus 2, because they are different ordered pairs. The distance from the center to a focus point is your C. So A is always the biggest. And then I also want you to put this in here. Now I'm going to draw in a dotted line. You can use a straight edge if it's helpful for you. But this is going to be parallel to the minor axis. And so tell me, based on what we, what we did with parabolas, what do you think this segment is called? The what? The focal chord. Good. So this right here is the focal chord. And if you know that length, then that can help you get an additional point on your ellipse to make your ellipse look better than if you just sketched it by hand. Okay. So then here, on this one, we're not going to label quite as much on here, but this is what I want labeled on here. This is focus 1, and this is focus 2. Right? And then we're going to put a point here that we'll just call XY. And then I'm going to draw a dotted line to this focus, dotted line to that one. I'm going to put another point like here, which we'll call another XY. And then I'm going to do the same thing. And I was not intending to make a rectangle, right? I mean, we could do this a bunch of times. We could keep drawing those in. That's basically like me holding my string out here and me drawing it this way. The dotted lines would be the two parts of my string that don't go between here. And this remains a constant length. So D1 and D2. So D1 plus D2 is constant. I'll have the official definition on the notes, on the next notes, just like I did with the parabola. It talks about the locus of points and blah, blah, blah. Okay. Everybody good so far? So fancy math word for an oval is an ellipse. An ellipse, not eclipse. Y'all know what an elliptical machine is? Yeah? Do you know why it's called an elliptical machine? What motion does your foot make when you're on it? But it makes an ellipse. It's not called an oval machine. It's an elliptical machine. It makes an ellipse, right? That's the motion that your foot's making. All right. So this little chart's going to go with your horizontal orientation, and this one with your vertical, and y'all can see both at the same time, and I can't. So when we learned circles back in geometry, H and K was a new thing, right? And it seemed kind of random, probably at the time. It might still seem random to you. I don't know, but H and K remains the center point for things that we do. So our center is still HK, and it does not matter what the orientation is, the center is still HK. Okay. Then there's some other things that remain the same as well. A is part of the major axis no matter what. So if my distance from the center to the vertex is A, then the length of my major axis is what? 2A, right? So the length of the major axis, make sure you're putting them in the box, is 2A on both of them. What would the length of the minor axis be? 2B. So those things are the same regardless of my orientation, right? Also the length of the focal chord, I'm just going to give that to you in the interest of time here. And you may not have enough room in the box. I couldn't make this box any bigger, so I'm going to go kind of underneath it. But it's 2b squared over a. 2b squared over a. We'll look at another way to come up with that, but those are the same. Now, our vertices are what change, right? If I get my center point here, which is, I will label this as HK, I guess, so we have something to look at here. I didn't want to put a C there, but we'll put HK. If I have that, then my vertices, what changes, my X value or my Y value? My X value. So for my vertex, the part that's the same as the center is the Y value, so it's still K. If I have the H value, how do I get a value for the vertex? For the X value for the vertex? I can add what? A, or I can subtract A. So this is going to be H plus or minus A. If you understand the picture, then you're not having to remember which one's what, you know, do I add it to X or Y here? Is it A or B or what's happening? Your co-vertices, what's changing there from the center? The X or the Y? The Y. So here my X value stays the same, and my Y value, which was K, I either add or subtract what? B. Now, if it has a vertical orientation, which you'll have to look up at the top there, my vertices aren't H plus or minus A. What changes in this one? The Y value. So it's K plus or minus what? A or B? A, because it's along the major axis. So remember, it's not that A always goes with X and B always goes with Y. It doesn't work that way. A goes with the major axis, B goes with the minor axis. Okay, H does go with X and K does go with Y, and that's all and always, but not the others. So for my co-vertices then, it's actually my H value that's changing, and that'll be plus or minus what? B, comma, K. Then my foci, they're always along the major axis. So they're going to have the same type of thing happening to them that the vertices do. So the K value is the same. But I don't go all the way to A. It's H plus or minus what? C. And here, H doesn't change, but it's K plus or minus what? C. We all good so far? One more thing on the front before we flip. A little kind of bonus information here. You have what's called the eccentricity of an ellipse. If we had time, we would talk about what eccentric really means, but we don't have time right now. We'll talk about that on another time. But the eccentricity of an ellipse is how circular or stretched it will be. So there's another little letter, it's E. And E is just the ratio of C to A. And E is always between 0 and 1. So the closer to 0, is the closer to a circle. If we look at this board, I don't know what the values actually are because I didn't measure any of this, but I know that this E value here is way closer to 0 than this E value, because this is more of a circle, right? And this is going to be closer to 1 because it's getting flatter and flatter. So if E does happen to equal 0, then that means it is a circle. Because that would be, if E is 0, then that means C has to be 0, right? What would end up making C 0 in our little equation here? These two being the same, right? And if these two are the same, then that's basically going to be R squared, and that's why it's no longer an ellipse and it's a circle. Okay, we good? Awesome. All right, so we may just have time for one example, which is really probably fine. I mean, I put 2 on here. I started to put more, and then I thought, I don't know that we really need that. This is very basic. On Tuesday, when we do the second day, we're going to have to write some stuff and do some other things. But here is your equation of an ellipse. Now, this is a plus, not a minus. We'll look at what happens when it's a minus. It's equal to 1. All those things are important. I should be able to look at this and figure out really quickly at least my A and my B, right? Down here, the bigger denominator always has to be A squared. So A squared equals 9, and B squared equals 4. It's easy. Don't mess it up because you're not paying attention and you don't do what you need to do. So what does A equal? 3. What does B equal? 2. Okay? And it's not a plus or minus thing. Now, C squared, we know, is A squared minus B squared. Well, I don't have to square them. They were already squared. So my C squared is just 9 minus 4. So C squared is 5. So my C is the square root of 5. We need a decimal in our head to be able to, or not, I don't expect you to do that in your head, but you would need a decimal in your mind is what I meant. You don't have to do it with your head. Square root of 5 is the answer you should have there, but when we go to actually graph things, we're going to need a number we could actually plot on the graph. Okay. Now, because of A and B and where they are, we should know if it's horizontal or vertical. Which one is it? Which one has the bigger, or which one does A go with, X or Y? X, right? And so if A is underneath X, it is horizontal. Okay, so this is horizontal. What is your center point? -2, 1. I'm going to go ahead and go down here and I'm going to plot that. I'm going to -2, 1. And I'm going to label it my center. Okay. Then we're going to go back up here. And your vertices, since it's the first time that we're doing this, I'm going to write it underneath where it says vertices. To find them, it's H plus or minus A, comma, K. Right? Because we know it's horizontal, so the actual vertices are along the major axis. So that's going to give me, I take my h, which is -2, add 3, and I get what? 1. So 1, 1. And then h, which is -2 minus 3, gives me -5, 1. Everybody good with that? So let's go label and plot those. I'm at 1, 1. That's a vertex. I'm at -5, 1, and that's another vertex. Okay. My co-vertices, those are going to be h and then k plus or minus b, because I'm coming from here and going vertically, right? So the ordered pairs that I get, I can't see mine, so I'm going to take, I know that my x value for both of them is going to be a -2. So k was 1. If I add 2, I get 3. If I subtract 2, I get -1. So I go and plot that. -2, 3, and that's a co-vertex. -2, -1, and that's a co-vertex. Oh, I got 8 minutes. We all good so far? And then the next thing I need are my foci. So my foci, to find those are always along the major axis. And in this case, it's horizontal, which means my x is changing, so my y stays the same. But to find that is my h value plus or minus what? C. Okay, plus or minus C for the focus, right? So what I want you to have written down is the exact one, which means I'll take my h value, which is -2. Be very careful. Here's what I did. I'm just going to tell y'all because I'll probably do it again, and some of y'all may do it. After I set it up this way, I found myself grabbing this as like the x and this is the y. Clearly it's not, but just, I don't know, maybe I circle that or something. That's kind of the one you always go back to, so you're using the right numbers, because all the numbers start to look the same. All right, so h, but of course I make more of the stupid mistakes than y'all do. H is -2 plus the square root of 5, comma 1, and then -2 minus the square root of 5, comma 1. Right? So those are our exact answers. But obviously to go plot that, I need some sort of decimal for these, and I'll just tell you what those are. Those are, I wrote them down. I didn't have to make you get calculators. This would be 0.236, and this would be -4.236. Okay. Everybody okay with that? So now when I go and plot those, my foci, 0.236 is like right there. That's a focus. And then -4.236, that right there. And there's my other focus. So if you wanted your graph to be beautiful, you could put a piece of cork down, and you could put little tacks on your foci, and you can make yourself a little string, and you can make your little, now you know how to make an ellipse, and you can go wow people at parties. Be like, look what I can do, right? I know you're going to do it. Don't even act like you're not going to. All right, so major axis, that is just 2 times what? A. And minor axis is 2 times B, right? And that gives us our lengths, which we could also count if we wanted to off our graph, as long as the numbers were pretty. But that means my major axis is 6. My minor axis is what? 4. Which happens to match what's in the denominator, but that's just because 2 is a special kind of number, right? So to find the length of the focal chord, we could, how do we do that? How do we find the length of the focal chord? Focal chord equals 2b squared over a, right? So b, what is b squared? 4. Like I don't even have to square it, it's already there. So this gives me 2 times 4 over what? 3. So that's 6 over, 8 over 3. Dang it, sorry, thank you. 8/3. No, you know I just can't multiply. It's 8/3. The eccentricity, what is that? That is c over a, right? What is c? Square root of 5 over 3. And then you don't really do anything with that number except it tells you how circular or non-circular it is. So it's 0.745. Just want you to understand that it exists. So at this point, I could, 8/3, right, is like 2 and what? 2/3, right? So I could from here go up to, and, I could go 1 and 1/3 this way and 1 and 1/3 this way and make another point. But at the same time, I don't have to, and I can just sketch it. It's like when you drew circles. You just do your best to make it look as elliptical as possible without it looking like whatever. Now, do you want to know why you might care about the eccentricity? Any of y'all been to the eye doctor? I see a lot of y'all wearing glasses. Okay. So I don't remember the exact numbers, but your eyeball is an elliptical type thing. It's not really a sphere. Okay, it's like a three-dimensional ellipse, which I think is called a folate. That's a weird word, but anyway, to have normal vision, you have a certain eccentricity to the ovalness of your eye, and then when you're nearsighted or farsighted, that stuff changes. So when you go to the eye doctor, before they even let you sit in front of there and they change things and they say 1 or 2, 2 or 3, and that sort of thing, they put you in front of a machine that sort of does it itself, right? And they kind of have an idea of your prescription, and then no, you get both of them. I'm sorry, don't pass them out. I didn't get to staple them. But anyway, they know by the eccentricity of your eyeball what your vision probably is. So when I had to go to the doctor because I was getting old and I couldn't see, and she was like, yeah, well, when you get your age, the shape of your eye changes. So the eccentricity of my eye changed, and that's why you have to go by readers to be able to see anything. So just so you know. There is a reason. Your doctor, maybe next time at the eye doctor, you could impress your eye doctor. Could you please give me the eccentricity of my eyes? And are they the same? Right. Okay, so this is very basic. Find this stuff, graph it. What I'm going to do is I will complete this video during 4th period. I will do the second example. If you want to go and, would anybody go and watch it? Otherwise, I'm not going to waste my time. Okay. Then I will go and do the second example so that you have that too. But since class got started a little bit late and we didn't have time for it. But I think it's fine. I really think that you could be fine without it, but I will finish it if you want to see it. Okay? Are we good? Any questions? All right. Leave my Cody boards here. I'm going to write his name on them. We're going to put them on the board.